Hi everyone, let's continue. Look at this example. Let C be the curve parameterized by gamma of t equals 2 cosine t, sine t, and t. Find a parameterization for the tangent line to the curve at the point 0, 1, pi over 2. Okay, so first of all, we want to find the tangent vector. Okay, so what is the tangent vector? So tangent vector is the derivative of the displacement. So v of t equals gamma prime of t. Okay, derivative of 2 cosine t is negative 2 sine t. Derivative of sine t is cosine t. Derivative of t is 1. Okay, and because we want to find the tangent line, okay, so imagine this is the curve. Let's say we want to find the tangent line at this point. Well, to find a line equation, we need a point on the line, and we also need the direction, right? How can we find the points on the line? Well, we can plot, we already have the points, right? That is 0, 1, pi over 2. Well, but this guy corresponds to what t values? So this is alpha gamma of what t value? We can have that. Well, that corresponds to when t equals pi over 2. Right, everybody? So when t equals pi over 2, then we get this point. So if we want to find the velocity at this point, we want to plug in t equals pi over 2. So minus 2 sine of pi over 2, cosine pi over 2, and 1. What's sine? Well, sine pi over 2 is 1. Cosine pi over 2 is 0. So we get negative 2, 0, 1. That is the direction. So with the direction and with the point on the line, we can define the line equation. Because we already used gamma to denote the curve, now let's use L to denote the line. Okay, the parameterization for the line is the point plus t times the direction. Okay, so 0 plus t times minus 2, so we have minus 2t. 1 plus t times 0 is just 1, and then we have pi over 2 plus t times 1, so t. Okay, so this is the parameterization for the tangent line. So far, so good. And if you want to ask what is t, t is any real numbers. Or you can say minus infinity less than t less than infinity. Okay, either way works. Okay, let's continue. Indefinite integral. So we have already talked about how to differentiate a parameterization, okay? And how to differentiate vector value functions. Now let's talk about how to integrate a vector value functions. Suppose gamma of t equals, the coordinate functions are x of t, y of t, and z of t. Okay, so let capital X, capital Y, and capital Z be the antiderivatives of the coordinate functions, respectively. Then the integral, the indefinite integral of gamma of t equals, we just integrate each coordinate respectively. Okay, so that's the antiderivative of x plus a constant c, and then antiderivative of y plus a constant d, antiderivative of z plus a constant e. So here we have 3 constants. Okay, because we have 3 dimensions. How about definite integral? A typo here. I want to say definite integral. Suppose the vector value function gamma of t equals x of t, y of t, z of t, and all the coordinate functions are integrable on the interval a to b. Then we just integrate each coordinate respectively. Okay, and then evaluate from A to B. Okay, which means we find the antiderivative, we plug in B, subtract, and use the antiderivative, we plug in A. Okay, let's look at the following example. Suppose we know the following about a moving particle. The particle is given by the acceleration. The particle is located at 3, -2, and 5 at time t equal to 0. The velocity at time equal to 0 is 2, 0, 4. Find the position vector of the moving particle at time t. Okay, so just like what we did in Calculus 1, given the acceleration, we integrate one time, will give us the velocity, right? So we have integral of, okay, let's do this. Integral of -3 cosine 2t, -3 sine 2t, and 2. Okay, integral of -3 cosine 2t. Well, integral of cosine is positive sine or minus sine. Think about the derivative of sine is positive cosine, so the integral of cosine is positive sine. And then because we use u substitution, so we need to divide it by 2. So that's why we have -3/2 sine 2t. Okay, so if you're not familiar with the antiderivative formula, please visit my website and look at the calculus formula sheet. Okay, and then you can also go to my Cal 1, Cal 2 course, kind of review the sessions that you're not familiar with. Okay, or find more practice for those sessions. Okay, and integral of sine is minus cosine, so minus become positive. Integral of, oh, you see what I did miss? I missed the constants. So every time you integrate it, don't forget the constant. Okay, so here we have plus c, here we have plus d, and integral of 2 is 2t plus e. Okay, and then we plug in v of 0. V of 0, we plug in t is 0, sine 0 is 0, so we just have c. And then cosine 0 is 1, so we have 3/2 plus d. And then we plug in t0, we just get e. So this guy equals 2, 0, 4, right? Our initial condition. Okay, that means c equals 2. Well then, 3/2 plus d equals 0, so d equals -3/2. And e equals 4. So v of t equals -3/2 sine 2t plus 2, 3/2 cosine 2t minus 3/2, 2t plus e is 4. Okay, and then we're ready to find the displacement is the integral of the velocity, right? Integral of the velocity. Okay, so let's see, what is the first one? Integral of sine is negative cosine, right? Negative become positive. And there is one more copy of 2 at the bottom. So this is what we get. Ooh, not yet. Integral of 2 is 2t, and then after we're done, we have another constant. So c, d, e, okay, f. And then integral of cosine is sine. So we have 3, but there's one more copy of 2 at the bottom. So 3/4 sine 2t, and then we have 3/2 t plus another constant g. Integral of 2t is t squared. Integral of 4 is 4t. So FGH. So far so good. And then we also plug in 0. We plug in 0, cosine 0 is 1. So we get 3 over 4. When we plug in t is 0, 2t is gone, and plus f. When we plug in 0, sine 0 is 0, t is 0. Oh, we only get g. When we plug in t is 0, the first two terms are gone. We only left with h. Well, that is 3 minus 2 and 5. So 3 over 4 plus f is 3. Then f is 3 minus 3 over 4. Well, this to the common denominator, 12 minus 3 is 9 over 4. And then we have g is minus 2, h is 5. So far, so good. So at the end, gamma of t equals, let's copy down everything. Let's see, let me move it here. Okay. So we have 3 over 4 cosine 2t plus 2t. F is 9 over 4. And then 3 over 4 sine 2t minus 3 over 2t plus g. G is negative 2. And then t squared plus 4t plus h. H is 5. Okay, so this is the displacement. So it's very similar to what we have done in Calculus 1. But Calculus 1, we just do one function. And here is like 3 times the work we did before because we have 3 coordinates. Okay, but the idea is the same, so we just generalize the idea and do it for each coordinate. Okay, next, let's look at this fact. Motion with constant display. This is the magnitude of the displacement. Okay, so let's gamma describe a path on which this is the distance from the particle to the origin. Okay, so the distance from the particle to the origin is constant. What does that mean? Well, it means in R2, your particle is moving on a circle. Do you agree? Because the distance from the point to the origin is constant. Then you're moving on the circle. In R3, what can you say? So in R3, then we're moving on the sphere, right? Because the distance from the points to the origin is the same. So we're moving on the sphere. Okay. So what do we get? We can conclude that the displacement dot the tangent vector equal to 0, which means the position vector and the velocity vector are orthogonal at all times for which the function are defined. Let's draw some picture. Let's look at the two-dimensional. Okay, so if you're going this way, okay, this is the position vector, right? And how about the velocity vector? The velocity vector is going this way, right? And you can see, it's true that they're orthogonal. Okay, so but how do we prove that? How do we prove that? Well, let's use the fact that the length of the position square equals gamma dot gamma, right? Yes, and this guy is constant. Now let's take the derivative of this guy. Take the derivative of that, we get derivative dt of gamma dot gamma. Well, this is gamma prime dot gamma plus gamma dot gamma prime. Okay, what is that? Well, derivative of gamma is velocity. Okay, and gamma dot velocity. This is just because dot product is commutative. right? Even though cross product is not commutative, but dot product is commutative. So this is the same as 2 times gamma dot v. And on the right hand side, because it's a constant, the derivative of a constant is 0. Ooh, so it means gamma dot v is 0. See, I didn't put an arrow on top of a 0 because dot product is a number. Okay, everybody keep in mind, dot product is a number, cross product is vector. Okay, don't get confused about them. Okay, so that's why now we see therefore gamma and the v, they are orthogonal. Okay. Similarly, we can extend this idea. Okay, so similarly, if the length, the magnitude of the velocity, which is the speed, okay, so the speed is constant, and then what do we say? Then we can say acceleration dot velocity equals 0. So acceleration and the velocity, they are perpendicular, they are orthogonal. So far so good, everybody. Okay, and it kind of makes sense because your let's say your particle is going this way, this is the velocity, right? And let's look at your acceleration. So usually your acceleration, it can decompose into 2 components. One component is okay, so one component is parallel to the velocity. Okay, so let me change my color here. So one component is parallel to the velocity. So this component will change the magnitude of your velocity. So if they're in the same direction, then your speed will increase. If they're of the opposite direction, then your speed will decrease. The other component is perpendicular, orthogonal to the velocity, and this component will help us to like change the direction of the velocity. Okay, so one component parallel to the velocity will change the speed. One component that is perpendicular to the velocity will change the direction of the velocity. Okay, you know a vector is made of magnitude and direction. Okay, let's continue. So now let's evaluate the following integral. Okay, let's look at the first one. We have a part A. Let's integrate each guy. So our answer, integral of secant square. What is the integral of secant square? That is tangent of t. So I hope you're familiar with the antiderivative formula. Okay, and this guy, we have the I components. Integral of cosine is sine, but because of the u substitution, we divided by 7. Sine 7t. We also evaluate from 0 to power 4 j. Integral of e to the 4t is 3 over 4. E to the 4t evaluate from 0 to power 4 k. So far so good, everybody. Alright, so which means we plug in pi over 4 first. Subtract, we plug in 0 times I minus 2 over 7. We plug in pi over 4, so 7 pi over 4 minus, we plug in 0 j. Then we plug in e to the 4 times pi over 4 is pi. E to the 0 is 1 k. Alright, and what is tangent pi over 4? you know, this is pi over 2, so at pi over 4 we get 1. So I hope you're familiar with those common angle value. And what is tangent 0? Is 0. So 1 minus 0 is 1, so we only get I there. Okay, what is sine 7 pi over 4? Sine right here. 7 pi over 4. Sine is 2 pi periodic. So 7 pi over 4 minus 2 pi is just give us minus pi over 4. So minus pi over 4 is right here. So it just gives us minus root 2 over 2. And sine of 0 is 0. Okay, but minus minus become plus. And the 2 cancel. We have root 2 over 7. J. Is that okay, everybody? And then let's copy the last term down. E to the pi minus 1 times k. Alright, yeah, let me write it down. So sine of minus pi over 4 is negative root 2 over 2. Okay, so this is part A. Let's look at part B. So before you calculate, you will need to simplify it, right? Here we have t times something. Well, we don't have a product rule or quotient rule in integral. So keep in mind, no product rule. So no product rule or quotient rule for integral. Okay. So which means if you see a product or quotient, there could be some way you can simplify to express it as a sum or difference. Then we can integrate. Or we learn something can help us to solve the integral of certain products. That is the integration by parts. Integration by parts can help us to solve the integral of when you see the polynomial times sine or cosine or exponential function, or you see a polynomial times inverse function. Inverse function, I mean natural log, arcsine, arccosine, arctangent, arcotangent, arcsecant, arcosecant. Or it could be a product of exponential function times cosine or sine. Okay, those three types of products we can use integration by parts. And for quotients, you might see some quotients that you can use partial fractions to calculate. Okay, so integration by parts is in session 7.1. And then partial fractions is in the session 7.4. If you forgot about those, feel free to go to my Calculus 2 websites and then go to the corresponding session to look at the notes and videos to review. Okay, or feel free to come to talk to me. I would love to help you. Okay, so in this case, we can distribute the t. So we have 4t to the 6i. Minus square root of 25 is 5. And then we have t times t. Square root of t is t to the 1/2 j. Okay, so for the k, here, how we calculate this, we're gonna split it, okay? So we're gonna split it as 3t over 16 plus t squared. And we want to split it as 8 over 16 plus t squared. Well, you might say, why do I have a minus? Isn't it plus? Because I still have my parentheses here. Okay, so I didn't change it to plus yet. Okay, now let's continue. So the first term, integral of t to the 6, we add 1 to the exponent. So it's t to the 7 over 7. And don't forget the 4 in front of it. So keep in mind, integral of t to the n, integral. So, sorry, I mean integral. Is t to the n plus 1 over n plus 1 plus c, right? And this is when the n not equals -1, because integral of 1 over t is just ln of absolute value of t plus c. Okay, so and then evaluate from 0 to 1. This is the I. Well, this guy is the same as t to the 3/2, right? So t to the 3/2 plus 1 is 5/2. And then we divide it by 5, multiply by 2. Ooh, 5 cancel. And we evaluate from 0 to 1, j. Okay, now, how do we calculate this guy? Well, here, let me move it here and separate into two integral, because the method to calculate each of them are different. Well, here we can see we can pull out the 8 outside. Here we can pull out the 3 outside. Okay. So how do we calculate this guy? Here we use u substitution. Let u be the denominator. Okay, because you can see the derivative of u is 2t dt. Well, t, you see t on the numerator. That's why when you see the bottom is degree 2, the top is degree 1, think about u substitution. Okay, so t dt is 1/2 du. Well, then this guy is 3 integral of 1/2, put it in front, du on top, and then we have the u. Oh, this is 3/2 ln of absolute value of u. Okay, plus c. And then u is 16 plus t squared. Why don't I need the absolute value? Because t squared plus 16 is always positive. Okay, and then for this guy, you use the formula of arctangent. Okay, from the arctangent, so 1 over a squared plus t squared dt is then 1 over a arctangent of t over a plus c. So that's why this guy, okay, not include the 8. Well, it's gonna be, what is a? A squared is 16, so a is 4. So this guy is 1 over 4, not include the 8 in front, okay? 1 over 4 arctangent of t over 4 plus c. So now let's see. This guy continue here. We plug in 1, so 4 over 7. When we plug in 0 is 0. I minus 2. We plug in 1, we get 2. We plug in 0, we get 0. J. Then we have here 3 times this guy. Okay, let's see. So we have 3 times 3 is 9 over 2 ln of 16 plus t squared. Evaluate from 0 to 1. Oh, sorry, I forgot the 0 to 1. There are definite integrals. Okay, and then the 8 and the 4, they cancel out. We have the 2 arctangent of t over 4. Evaluate from 0 to 1. Okay, so we have 4 over 7i to j. This guy is, when we plug in 1, we have ln of 17. So 9 over 2. Oh, sorry. When I calculate, I already include a 3. So here it should be 3. Okay, so I already included 3, so I shouldn't multiply one more copy. So this is ln of 17. Then minus when we plug in 0, so 3 to ln of 16. Do you know what is ln of 16? Well, 16 is 2 to the 4th. So this guy is 2 to the 4th, but you can move the 4 in front. So this cancel. We get 6 times ln of 2. Alright. And then when we plug in 1, we get arctangent of 1 over 4. That's not a common angle value. The common angle value are 0, 1 over root 3, 1, and root 3. So this is not a common angle value, just leave it there. And then when we plug in 0, our tangent of 0 is 0. So just leave it like that. Okay. Okay, now let's see. We can simplify like one more step. I and j stay the same. This negative, we can distribute it. So it becomes negative 3 half ln of 17 plus 6 ln of 2 plus 2 at tangent of 1 over 4. Okay. So this is the final answer. So far, so good, everybody. Let me move this up a little bit. Okay. Oops. Okay, so this is the final answer. In general, how do you figure out what is arctangent of a number? Well, you think about the graph of a tangent. So this is the graph of a tangent. Well, then the x values of the arctangent corresponds to the y value of the tangent. Okay, so if you want to ask what is arctangent of 1, that corresponds to, you want to ask if the y value is 1, what is the x value? Well, that is pi over 4. Then what is the arctangent of root 3? Well, think about it, root 3 is right here. What is the x values that corresponds to, like tangent of that x value is root 3? Well, that's pi over 3. So far, so good, everybody? Okay, so I try to like remind you what concepts we should know when we go over like different parts. Okay, yeah, this is Calc 3, so all the previous courses include algebra, trigonometry, Calculus 1, Calculus 2. So it's hard to like review all the things in our course. So when we go over some problems and you have questions, feel free to ask me. And if I can remember, then I can direct to you like what concepts we're working on, and what sessions in Cal 1, what session in Cal 2 we're referring to that you can practice with. Okay, so so that is sessions 11.6 and 11.7. So please work on your homework, and if you have questions, feel free to ask me. Have a nice day. Bye.